Hi everyone, welcome back to Cupilon Online Education Learn Perfect. So today is our one of the new topic, that is half-wave rectifier and the full wave rectifier. Okay, so before that we must know what is this rectifier. The rectifier is a circuit which can convert to AC current to AC, the current to DC. Okay, or sometimes they will ask one more question, what is rectification? It is the process of converting AC to DC. Clear? So here rectifier is one of the circuit. That circuit can convert the AC current into DC current. And here two rectifier circuits are there. The first one is the half wave rectifiers and second one is the full wave rectifier. Clear? First one is the half wave rectifier and second one is the full wave rectifier. Okay, so here, and what is the purpose of this half wave? What is the use of this half wave and full wave rectifier in our daily life? See, one thing you know that AC current. So AC is, how the AC current is there means it is the sinusoidal wave. So it is like that, one positive, negative and positive and negative. So like that the AC is, that is the AC current. So it is the positive and it is the negative. This is the positive and this is negative. Here the AC current we can't store. Instantly we have to use it. Mean when the AC current is manufacturing, when AC current is generated, immediately within the fraction of second we have to use it. Okay, immediately we have to use it, or else that will be gone off. So like a thunder, once the thunder comes in the sky, so immediately it will be disappear. Even AC current is also like that, we can't store it, but we can store DC current. But normally we are manufacturing or we are producing AC current because that is the cheapest as compared to the DC, and AC is good for transport from one point to another point, from one village to another village. Easily we can transfer that one. DC we can't transfer such a long distances. So for that purpose we are starts producing the AC current, but AC we can't store it, but DC we can store it. Are you clear? Okay, so and in our house, the sum of the electronic gadgets like the mobile phone, TVs and computer, laptops, so these are all work with the DC, but they are not work with the AC. But we are giving the AC supply, but that AC is converting into the DC, that DC which is utilized by the electronic gadgets. Okay, for that purpose we have to convert this DC. So compulsory the DC current is need for somewhere. So for that we have to convert. How we are going to convert means we are using the two methods. So that is half wave rectifier and the full wave. Two rectifiers are there, but most means commonly we are using the full wave rectifier. But what about the half wave? Why we are not using? Why we are using full wave? We will study one by one clearly. And so before starting half wave and the full wave rectifier circuit, I request you dear students, please press subscribe button, and along with the bell icon. So along with the bell icon to get every new notification whenever I upload the new video, so immediately you will get the message. Through that message you can see whatever the new video I uploaded into the YouTube. Okay, clear? Okay, thank you, and thank you for your support also. Now we will start one by one. The first one is half wave rectifier. So first let me draw the half-wave rectifier circuit. So first we have to take one of the transformer. Okay, this is the transformer. Okay, here in transformer there are two coils are there. So here I will connect one diode. Here a diode plays a very important role in this rectifying circuit. So this is the resistance, that is the RL, load resistance. So here we are taking the output. So this side is, that is the input, and this is connected to the AC source. So this represents AC. Okay, this represents AC. So this is AC current. So this is the transformer. Okay, now you listen here carefully. So this is the transformer, and in transformer there are two types are there, step up and step down transformer. So we are using the step down transformer. Step down means it is reducing the voltage, decreasing the voltage. Step up means increasing the voltage. So in this half-wave rectifier I am going to take step down transformer. So primary, these two are the, this is the primary coil, this is the secondary coil. Every transformer has two coils, one is the primary coil, one is the secondary coil. Okay, so this is the primary and this is the secondary. Okay, the primary coil is connected to the AC source and secondary coil is connected to the diode, that is the D. Okay, diode D. And other end of the negative terminal of the diode is connected to one of the resistance, that is the load resistance. Across the load resistance we have taken the output. So this is the construction. Next, working. What is the working? How does it working, this circuit? Okay, so working is very important, construction and working. So here I will make the 2 points. So this is the point A and this is the point B. 2 points. Okay, so first one, see, point wise point you try to understand. I'll tell even point wise also. So first point, the point number 1, when AC current is supplied at the input of the primary coil of the transformer, so immediately in the secondary coil the EMF will be induced. EMF is nothing but as the voltage. When voltage is produced, automatically current is flowing. Are you clear? So this is the graphical representation of the AC current. See, this is the sinusoidal wave, like that, sinusoidal wave. Okay, then just we have to take one more diagram after converted. So this is the input. So this is the input we are sending to the circuit. So here this diagram is represents, that is the output. So carefully you listen. See, when the input primary coil, is connected to the AC source, when AC current is passed in a primary coil, the immediately in secondary coil EMF will be induced. When EMF is induced, immediately the current is produced. But produced current as like this. Okay, produced current as like this wave, means one positive and one negative. So one is the positive, one is the negative, and positive and negative. Okay, see, and one more thing, what is the frequency of AC? The frequency of AC is 50 Hertz. Frequency of AC is 50 Hertz, means it indicates if you count 1 second, within 1 second that AC is completing 50 cycles, like that. 50 will be complete in 1 second. So that is called frequency, number of cycles completing per second, that is called frequency. In 1 second the 50 cycles will completing. So that is the frequency of our AC, what we are using in our home, that is the frequency is 50. Here we are just discussing, and just imagine within the second only we are discussing here diagram. So in 50 cycle, 50 positive will be there, like that, 50 positive will be there and 50 negative will be there. Okay, during the first point, that is the second point, during the positive cycle, when this cycle is entering, when this cycle is at the point A, during the positive cycle, the point A will become positive and the B will become negative. When A is positive, again here diode, the positive, here this side of the diode is, this side is positive terminal, this side is negative terminal. Positive is connected to positive, means positive cycle to positive terminal of the diode, it is said to be forward bias. Okay, that is said to be forward bias. When the diode is forward bias, it conducts the current. And diode is a device, one more thing, diode is a device which allows the current in unidirectional, means only one direction. Once it is passing from left to right, it won't allow back. That is called unidirectional flow of current, which allows. Okay, again you come to the point. At the point A, is during the positive off cycle, okay, during the positive off cycle, the point A will become positive, point B will become negative. That time the diode is set into forward bias, that diode is conducts the current, and output we are getting the converted DC, like that DC is converted. Okay, just you draw like that, point dotted for every off cycle. Okay, so this is also one more. Half of the cycle, positive half cycle is converting into the DC. Okay, so immediately the A will become negative, B will become positive during the negative cycle. During the negative cycle, the A will become negative, clear? B will become positive. A is negative, means negative and positive, the diode is set into reverse bias. Next condition. When it is reverse bias, the diode won't conduct current. There is no current is coming outside. So that time what will happen? There is no conversion is happened in the during the negative cycle. Next immediately this cycle will come. When this cycle comes, A will become positive, B will become negative. Clear? That time diode is conducts the current. Again this positive cycle is converted into this DC, like small DC. Again next negative cycle, the A will become negative, the diode is set into reverse bias. That time diode won't conduct, the again here is the missing the negative cycle, means it represents there is no conversion takes place of the negative cycle. So it means that half of the cycle, so here positive half cycle, here is also positive half cycle, here is also positive half cycle, is converted into DC. Okay, DC, but not complete wave is not converted, means almost 40%. So we will get the efficiency of this half wave rectifier is 40%. If you send 100% AC at the input, it is going to convert 40% at the output. So this is the half wave rectifier. Are you clear? Next we have to go for full wave rectifier. So in half wave rectifier, is drawback is it converts only half of the cycle. It won't convert the full cycle. So for that efficiency is very less, 40%. Okay, we are supplying 100%, we are getting back only 40%, means it is not good. So then we have to move for full wave rectifier. So how full wave rectifier is working and what is its circuit diagram? So now we have to go for the full wave rectifier. So in full wave rectifier, so we are using the two diodes, and before that let me draw the circuit diagram. So transformer, so it is like that, number of turns, that is the primary coil, and this is the secondary coil of the transformer. And here one of the special transformer we are using, so this is the diode 1, so this is the D1, And here also we are connecting one more diode. Actually in full wave rectifier two diodes we are using. Okay, in half wave rectifier we have taken here output, but here one of the special, that is the center tapped transformer. Carefully you listen, center tapped. Here one more connection is there. Within this connection we are connecting the load resistance, so that is the RL. Here we are going to take the output. Okay, so this is very important. Sometimes they will ask what is the difference between half wave rectifier and the full wave rectifier. So in half wave rectifier we are using one diode, full wave rectifier we are using two diode. In half wave rectifier we are using the normal transformer. In full wave rectifier we are using the center tapped transformer. So this is the primary coil, so this is the secondary coil, and step down transformer we are using. Okay, here we are supplying AC, this AC current we are supplying at the input. In output we are getting the DC. Okay, here the point, that is the point A, and this is the point B. Okay, and for this also we are going to take the wave diagram. So like this. Okay, the sinusoidal wave I am going to take. So this is the sinusoidal wave, and that wave is, this is the input wave. Input we are supplying this wave. So how we are getting the output, we will draw along with the discussion. Okay, so this is the full wave, this is the circuit of full wave rectifier. The carefully you listen. Now first one is construction. Okay, how we have to construct. So construction. See, construction is that when primary coil of the transformer, center tapped transformer, is connected to the AC source, and secondary coil of center tapped transformer is connected to the two diodes D1 and the D2, and the third point, a output we have taken at the center tap of the transformer as shown in the figure. That is the construction. 3 points. Okay, and then we have to go for working. How does it is working? Okay, working we have to. So first point, when the AC current is supplied, or when AC current is passed through the primary coil of the transformer, so immediately in secondary coil the EMF will be induced. Carefully you listen, the EMF will be induced. When EMF is induced, immediately the current is produces. That produced current, current of AC is 50 Hertz. So 50 cycles are going to form in 1 second. First I am going to take the positive cycle, then negative cycle, and again positive cycle, and again negative cycle. During the point number 2, during the positive cycle of AC, the point A is set into positive. So this is the positive terminal, this is the negative, here is also positive, this is the negative. The diode, because positive means forward bias, this diode D1 is sets into forward bias. Clear? The diode D1 is sets into forward bias. So at the time, so when A is the point A is positive, that time the B is negative. So negative and positive, this diode is set into reverse bias. Reverse bias means it won't conduct. The diode 1 is conduct. The diode 1 is conduct, diode 2 is not conduct. So when diode is conduct, this positive of cycle, see, we have to take like this dotted lines for this graph. When diode D1 is forward bias during the positive half cycle, this positive half cycle is converted into DC like that. Okay, next point. So immediately the A will become this negative cycle. Negative cycle is flows at A, means at the time A will become negative, that time B will become positive. During that time the diode D1 is reverse bias. Clear? Then the diode D2 is, it will become forward bias. Now during the negative off cycle, the diode D2 will become forward bias. In that case, the diode D2 is conducts, the D1 is not conducts. So due to that, the negative off cycle is converted by the diode D2, that is converting into DC. Next, immediately during the positive cycle, next positive cycle will start. When positive cycle starts, the A again it will become positive, the B will become negative. That time the diode D1 is sets forward bias, okay, that sets into forward bias, and diode D2 is sets into reverse bias. That time this positive third, that is the second positive cycle, is converted into DC. Then immediately when negative cycle starts, the A will become negative, B will become positive. That time the diode D2 is conducts and D1 is do not conduct. So that negative off cycle, remaining negative off cycle is converted by D2. See, one thing you understand is the D1 is converting positive cycles, D2 is almost converting the negative cycle. So finally we achieved the full wave is converting into the DC. So this is the output, this is the output. The full wave we converted into this DC. Okay, here what is the efficiency? So suppose if you send 100% here, which gives almost 82% of AC is converting. So AC to DC is converted 82%. The remaining 80% of AC will be left in that DC. In that DC, the remaining 80% of AC is present, so that we call it as the ripple factor. What is the ripple factor? Means ripple factor is what is the AC component is present after the conversion of AC to DC is called ripple factor. So maximum 82% we are converting AC to DC, and remaining also we can convert it further 10 or 15% by using some other circuits are there. Okay, that will be, we will discuss in some other classes. Now we have only half wave and the full wave rectifier. Are you clear? I think you all understood very well. Okay, so this is the full wave rectifier, and just point wise point you can write very clearly. So how means, just see, when the AC current is flowing, so when point A is become positive, that time diode D1 is conducts, at the time diode D2 is not conduct because this point B is negative. So next the B is positive, A is negative, that time diode D1 is not conduct and D2 is conducts. So like that it will be gradually is going on, continuously it is going on, positive negative, positive negative, positive negative. In 1 second 50 cycles converted by D1 and 50 cycles negative cycles converted by D2. Like that it is going on. So finally we can convert it. In final exam, if they ask the full wave rectifier, you write the first you put the diagram, then write the construction, then working and point wise point. Okay, I think you are all understood very well. And one more, till now who are not subscribed to my channel, please subscribe to my channel along with the bell icon, and you will get every new upload, you will get the message. Through that you can watch my video. Weekly 2 or 3 videos are regularly it is uploading to our YouTube channel. So thank you for watching and thank you for your support, and have a nice day. Bye bye, take care.